Hi guys, well, welcome to the next video. So today we're going to be covering on how to write in standard and point slope form. So let's go ahead and get started. So first I want to discuss linear relation. So linear relation occurs when points on a graph line along a straight line. It is called a linear relation. Again, it's when these points form a straight line. Linear relations can be represented by an equation. For example, the equation of this graph can be written as x plus y equals 8. To some of y'all, this may not be very familiar as this equation is written in standard form, which we will discuss in just a bit. Typically, most students are used to seeing these equations written in y-intercept form, which this equation would be y equals negative x plus 8. This is traditionally what most students are used to. So let's go ahead and dive on deep into standard form. So standard form, linear equations are often written in standard form, which is ax plus by equals c. So again, you're going to have your x value first with its coefficient plus by equals c, where c is our constant. Okay, now we do have certain rules. A, B, and C are integers. Okay, so these are whole numbers. Okay, and A has to be greater than or equal to 1, which for a lot of students this also means it needs to be positive. That's usually the biggest trick that students fall for. And the last rule that we have here is that the greatest common factor of A, B, and C is 1. In other words, we need to simplify. So we want to make sure that we have the 1 correct order, 2 that A is greater than or equal to 1, and 3 we need to simplify. All right, well, let's go ahead and move on, and let's do some practice problems. So when we're looking here at number 1, let's go ahead and go over our rules again. We want to make sure that we have the correct order of ax plus by equals c. So when we're looking at this problem, we see negative 5x plus 6y equals negative 12. So we have our a values, our ax, our by, and our c. So our order is good. When we start looking at our second step, okay, where we want to make sure that a is greater than or equal to 1, when we come to the problem here, we see that we have a 5x. Okay, more importantly, we have a negative 5x. So we can't have this negative. So if I want to make this negative and I want to transform it to become a positive, I can't just change this negative 5x to a positive 5x. I need to multiply the whole equation by a negative 1. So when we distribute this, it will be changing the sign of every term in this equation. So negative 1 times negative 5x is 5x. Negative 1 times 6y is negative 6y. And that's going to equal negative 1 times negative 12, which is positive 12. So now does this satisfy a being greater than or equal to 1? Yeah, it does. And our last step, we want to make sure that we simplify. So we're looking at that greatest common factor. Well, I look at 5, 6, and 12. And I want to think, is there a factor that divides 5, 6, and 12? Well, factors of 5 would just be 1 and 5. 6 is not divisible by 1 or 5, and 12 cannot be divisible by 1 or 5 either. So this is good. We have 5x minus 6y is equal to 12. And this is our equation in standard form. Let's try another one. So when we're looking over this problem, we want to make sure that we follow the same steps, right? So step 1, we want to make sure we have the correct order. So that would be ax plus by equals c. Our second step is we want to make sure that our a value is greater than or equal to 1. And our third step is we want to simplify for our greatest common factor. So when we have this equation of 9x plus 6y minus 24 equals 0, we want to look at the order. And the first thing that we should be identifying is that our constant value of negative 24 is on the wrong side of the equal sign. So we're going to go ahead and move them over there. We can do that by adding 24 to both sides. So we would end up getting 9x plus 6y equals 24. Now this satisfies our order. When I look at step 2, it says a has to be greater than or equal to 1. Well, our a value here is 9, which is greater than or equal to 1. So that's satisfied. Our last part is we want to simplify and look for our greatest common factor. Well, factors of 9 would be 1 and 9, but 9 cannot divide 6, nor does it go evenly into 24. Well, we can think of 3 times 3 is 9, okay? 3 divides 6, and 3 divides 24. So when we divide everything by 3 to simplify, 9 divided by 3 is 3x. 6y divided by 3 would be plus 2y, and that will equal 24 divided by 3 is 8. And this is our equation in the most simplified form. Cool, let's go ahead and move on. So slope-intercept form, you guys know this typically as y equals mx plus b. Or in this class, we'll explore it more as f of x equals mx plus b. In other words, this would be when we discuss f of x, we were talking about the function of x. And we'll discuss that more later. Well, we know that m is our slope and b is our y-intercept. So when we talk about slopes, slope is a constant rate of change between the point. You guys typically know this is rise over run. There's 4 types of different slopes, and we're going to go ahead and just observe the sketch. When you see positive, okay, when you see these positive slopes, we're going to be going up or rising, increasing from left to right. When we have a negative slope, we're going to be going down from left to right. We would be decreasing. If we have a slope of 0, where m equals 0, that means we're going to have a perfectly horizontal line. You might see an example of this like y equals 1 or y equals negative 8. These are going to give us horizontal lines. When we have an undefined slope, when you think of vertical lines like the graph says here, we have these up and down, that's when we have an equation that starts with just x. That could be like x equals 1 or x equals 5. There is no y value. So during the whole time of these graphs here, x is 1 for all values of y, and x would be 5 for all values of y, and that is how you get your vertical lines. We'll discuss that further later in class. So let's do some practice problems. We want to make sure that we get this in y-intercept form, so that's going to be y equals mx plus b. And we're going to want to graph this. So our steps for this: 1, we want to make sure we get it in the right form. 2, we want to identify m and b. And 3, we will graph. So let's look at this equation here. We have y equals 2 over 5x plus 7. This satisfies the form as we have y equals our slope, x plus our y-intercept value. So we move on to identify m and b. M in this case is 2 over 5, and b is 7. You always want to start graphing with our b value. This is our y-intercept. This is where it's going to intersect the y-axis there. So when we go to y equals 7, I'm going to come up here to 1, 2, 3, 4, 5, 6, 7. And I'm going to put a point here. This is our y-intercept. Okay, now this is where it gets interesting. For our slope, this is going to be our rise over the run. So when we rise 2, we're going to come up 1, 2 units, and we're going to be a little bit off the graph, and we'd run 5. So 1, 2, 3, 4, 5. And our value would be up here. Now what I'd like, especially my Algebra 2 students to understand, is you can also do the reverse operations for this. And we can actually drop 2, 1, 2, and go 5 to the left, 1, 2, 3, 4, 5. And we satisfy the same graph. And then we're able to, okay, we're going to be able to graph our line, which would run this way. And there's certain principles that you want to be able to see, like for sure we cross the y-axis at 7, but we also notice that our slope is 2 or 5, which importantly is a positive slope. So we should be able to see that it is increasing from left to right. Okay, let's go ahead and move on. And let's look at this example here. So we have 4x plus y minus 1 equals 0. The first thing we want to do is we want to make sure that we can write this in the correct form. That form being y equals mx plus b. So when I look at the left side of the equal sign here, I know that I am going to have to move my 4x to the other side. Y stays on the left side, but I also want to move this -1. So let's go ahead and do that now. If I say 4x plus y minus 1 equals 0, if I want to move this 4x, well, I'm going to want to subtract 4x from both sides. These simplify out. We have y minus 1 equals -4x. So then we are then going to want to be moving this -1 over. To do that, we need to add 1 to both sides. These simplify out. We have y equals -4x plus 1. This would be where our m, our slope, would be -4, and our b would be 1. So when we begin graphing, we want to make sure that we come over to our y-axis. We start here at 0, but we're going to go up 1 because we're going to cross here at 1. Okay? And that's when we'll start our rise over a run. When we do rise over a run, we see it's at -4. So we're going to want -4 to be a fraction. So we're simply going to put this over 1. Where -4 is our rise and 1 is our run. So if I'm here at 1 and my rise is -4, I'm going to go 4 units down. So I'm going to go 1, 2, 3, 4, and I'm going to run 1 unit. I can do that again from here and go 1, 2, 3, 4, and then we run 1 unit. So when we draw our line, we're going to have something that looks very similar to this. Hopefully your graph looks better than mine. And we can check our answer by looking at our slope value. Our slope is a -4, so we should be going down from left to right. Alright guys, that's going to go ahead and conclude our video for the day. We will definitely do more practice problems during tomorrow's lesson. Y'all have a good day.